first, a little vocab for you. So a tangent line that's drawn to a circle is a line that intersects the circle in one point. So you can see up here how line M only touches the circle at one point at P. That is your tangent line. And the other definition is a secant. A secant intersects the circle in 2 points. So basically you take a chord, if I had just from A to B, that would be a chord. But the second I extend it out into a line, now I have a secant because it goes through the circle at 2 points. Okay, so another rule here is the exterior angles of a circle. So if you look at number 1, it says that we have PAC and PBD are secants. They go through the circle, touching it in 2 places. The measure of arc CD is 70 and arc AB is 20. And we want to find the degree measure of angle P. Well, angle P is an exterior angle. It's outside of the circle. Using the theorem up above, you take half the difference of the intercepted arcs. And difference means to subtract. So to get angle P, it is half of the difference of the intercepted arcs. Now, if you extend out, let's see how well I can trace this. The intercepted arcs are the 2 arcs, oh, kind of shaky over there, the 2 arcs that are inside of those extended secant. So here I've highlighted the 2 intercepted arcs. And you have to do the larger minus the smaller, otherwise you're going to get a negative answer and that won't make sense. So it's half of the larger intercepted arc, 70, minus the smaller one, which is 20. So we are going to do the parentheses first. 70 minus 20, 50. Half of 50 is 25. So angle P is 25 degrees. Okay, number 2. Same thing. We can tell that angle 1 is outside of the circle. Okay, so it's an exterior angle. It's half the difference of the intercepted arcs. If you extend out your secants there, the arcs that you are going to subtract have to be inside of those secants. So it's these 2 that I've just traced in blue. Well, we know the larger one is 111. Okay, so it's a larger intercepted arc. Now we have to find the smaller one here. Well, we have a full circle, which is 360. And if you add up those 3 arcs, the 104, 104, and 111, you get 319. So we're just going to subtract that from 360 to get that intercepted arc. And it comes out to be 41 degrees. So 41 degrees is the smaller intercepted arc. So to get angle 1, we're going to take half of, subtract those 2 arcs, we get 70. And half of 70 is 35. Number 3. This case, you have 2 tangents because they touch the circle. If you look, one place, 1 point over there as well. Okay, so angle 1 we want to find. It's an exterior angle. It's half of the difference of the intercepted arcs. And the intercepted arcs, let me highlight. I just highlighted in green the 2 intercepted arcs. Now the larger one here we don't have. We do have the smaller one is the 138. So we have to find that larger intercepted arc. Well, again, if a full circle is 360. And if you subtract that 138, you're going to have the rest of the circle. So it comes out to be 222. So this is the arc over here, the larger one. And then we can find angle 1 by subtracting 222, that intercepted arc, and the smaller one, 138. If you subtract those 2 arcs, you get 84, and half of 84 is 42. So angle 1 equals 42 degrees. Okay, another one. Tangent DA, I'm on number 4 here. Tangent DA, you can tell it touches the circle at one place. Secant DBC, it goes through the circle, touching it twice. That's why it's a secant. Are drawn to circle O from external point D, such that, this is important here, arc AC is congruent to arc BC. So I'm just going to label that. If the measure of arc BC, okay, so around here is 152 degrees, so this part on the outside. Determine and state the measure of angle D. Well, again, angle D is an exterior angle. It's half the difference of the intercepted arcs. Let me highlight the 2 arcs that we're going to have to subtract here. Okay, so this larger green arc we actually do have because it said that from A to C, it's congruent to BC, and BC was 152. So we know that's 152, and that's going to be the larger arc. And we have to take the difference. It's 152 minus the smaller green arc here. How do we find this? Well, again, a full circle is 360. So if you take 360, I'll go over to the left here. You take 360, and we know these two arcs are 152 and 152. Okay, so what you're going to do is subtract 304, that's 152, 152 added together, and you get 56. So this arc over here in green is 56. So the two arcs we're subtracting for the intercepted arcs are 152 and 56. Okay, so angle D equals half of, subtract those arcs, you get 96, and you take half of 96, and you get 48. And we're going to do one more problem in the video just to show you a backwards problem here. Okay, so number 5 says that we have two secants. We can see they go through the circle twice. Angle P is 40, so already it's different because we have the angle. Arc AD is 120, and we don't know arc BC, which is X. Now, those are the two intercepted arcs. If you look, they go right here, 120 and the X. You can see how they're inside of the secant. So those, if you extend the secants out, they're both inside of it. So the rule is the angle, I always like to write it as an equation, the angle is half of the difference of the arcs. Okay, now let's plug stuff in. The angle is 40. It equals half of the difference of the intercepted arcs. Now the larger arc has to go first. You can tell in the diagram, 120 is larger than the X. Difference is subtraction, and we don't know the smaller arc. To solve this equation, what I do is I multiply both sides by the reciprocal. The reciprocal of 1/2 is 2. 2 times 40 is 80. Half of 2 just cancels out because it's 1, and then we bring down 120 minus X. Subtract 120 from both sides, and you get negative 40, which kind of seems wrong, but then when you look at what you have on the other side, you have a negative X, or really like a negative 1X. If you divide by that negative 1, it comes out to be 40. So that arc is 40 degrees.